Okay, so we're going to be using the calculator for this lesson, so let's all make sure our calculators are where they need to be. Alright, so what I would like for you to do is go home, press the home key on your calculator.
I would love to go home. Yeah.
We'll go home pretty soon. And I want you to go ahead and clear. And then remember, you can clear all this out by doing F18. We're just going to get a new start. So F18 clears the home. Then I also want to make sure you clear your variables. Okay, you might have something stored in for X. We need to clear that out. Okay, so you're going to do second F1, and that's going to clear all your variables. So you're going to press enter. Yes, we want to do it, so enter again. Okay, I also want you to see that your mode, this stuff down here, looks like mine. By the way, do any of yours have a little BATT down here? Anybody? Say BATT? That means your batteries are low. Okay, but you need to be in Radians mode, you need to be in auto mode, function mode, all that. Are we all good? Okay, so most of what we're doing today is just the stuff we've already been doing, but it's a little bit more complicated of numbers, so we're going to use the calculator. But I am going to show you a few new things. So first off, with this f of x, okay, we're given an f of x. How do you know where f is increasing? When what changes positive? The derivative. So what do we need to do first?
Take the derivative.
We need to find the derivative. Now you could actually find this derivative by hand, but let's just go ahead and remind ourselves how to do this on the calculator. So I want you to press F3, calc, and feel free to write notes on this paper if you need to. Differentiate, and I want you to type in the equation. And don't forget your comma x close parenthesis. So we could do this one without the calculator, but again, I just want to practice it because we're going to have some coming up later next week that you really need the calculator for. Now, when you press enter, you should get something in terms of x. If you get like a number, that means you didn't clear your variables. You have something stored in for x. Okay? So you should have what I have. Do we all have the same thing? Yeah.
Two arguments.
Did you do comma x?
Yeah.
Close parentheses?
Wait, do I do it? Yeah.
I mean, look at mine and look at yours. Something's not matching up.
I did double parentheses on this.
Okay, that'll do it. Okay. So taking derivative is a good first step. What do I need to do now with the derivative? What'd you do? I'll need all y'all to put your phones away. Too many people. It's so easy to get distracted. I really need y'all with me on this because I want us to have no homework so we can get through this. What do we need to do with the derivative? Set it equal to 0. Okay, I'm going to show you a couple of different ways to do this. The first way is through the F2, solve. So I'm going to solve. And I need to put in an equation here. So if you press the up key, it'll highlight what you got for your derivative. And if you press enter, it'll paste it right there into, it's like copy paste. Okay, and we want to set the derivative equal, so put the equal sign over here on the left, equal to 0. Well, we're not yet. You're going to go equal 0, comma x, close parentheses. Now, your calculator's going to say busy. It's going to give you a warning, and it's going to take about a minute to do. Okay, the reason, so while it's doing this, let me explain to you why this happens. This is a trig equation, right? We have trig in there. Trig goes up and down and up and down and up and down, and it could have infinitely many solutions. So it takes your calculator a while to find them. All right, and so mine's still working. Anybody got theirs yet?
Someone making calculator and like more solutions than knows already.
They're really smart.
They're incredibly smart. Mine like answered it right away.
Yeah, no. I don't know why some calculators take longer than others. I have no idea. Okay. What? It's an error? What So something was not typed in right. All right, now, okay, listen. Once you get these numbers, by the way, you can go right up here. Uh-oh, there we go, okay. Go right up here, press right. That's how you can see the whole number if you need to, okay? So negative 3.682. Let's write this down. And these are our critical numbers, by the way. And x equals 0.191. Now, because this takes a while, and on some it even takes longer than that, I'm going to give you another way to do this. On some trig equations, it won't find it at all. Okay? So you may like the second way better. It may not be a backup. It may be just the way you want to do it. Okay? So we're going to go to y equals. Y equals is the same color as your diamond key. So we're going to go diamond F1. If there's anything in your y equals, clear it out. And we're going to type in our derivative. You could copy and paste it. It's not as easy as like what I showed you before when you were in the home screen. So I'm just going to retype it. Okay, so there's the derivative. And what I'm going to do is see on the graph, where is this derivative equal to 0? Okay? So you just type the derivative into y1. And so you're going to go to F2, which is zoom. And this is the same zoom menu you had on your calculator before this class. So which zoom did you typically use like more than anything else? Zoom standard, which is zoom 6. So we're graphing the derivative. This is the graph of f prime, not the graph of f. So I want to know where this derivative is hitting 0, here and here. Okay, you remember how in your old calculator you did second trace a whole bunch? Second trace, and then all the different options. On this calculator, all you got to do is hit 5. Just think, that's where you go to do your math. So hit 5. And see where it says 0? That's saying 0 like root or x-intercept. See where it says lower bound? That means, are you to the left of that root? Yes, I am to the left, so press enter. Now it says upper bound. So now you go to the right of the root, press enter, and it will find the 0 or the root or the x-intercept that is between those two bounds. So see, we get the exact same number, 0.191. Okay?
Will you explain?
So I'm going to do that again.
Okay.
I'm going to do that again with the other one. So you're going to do F5 because that's where you go to do your math. You're going to select 0. So you can press 2 or go down and press enter. And now if I'm trying to find the 0 over here, I need to go to the left and press enter. Lower bound doesn't mean below. It means left. Okay? Upper bound means go to the right. Enter. And it will find that. It'll say 0, and then you just look at the x value.
What if yours isn't giving you a value?
What do you mean it's not giving you a value?
It won't give me a number.
I don't understand what you mean.
Oh, never mind.
Okay.
How do you zoom again?
Huh?
How do you zoom?
You do F2 zoom. So I just do F2 6, and that just gives me my standard zoom. Okay, so what I just showed you was an alternative way of finding these two numbers. You have two tools in your toolbox for finding critical numbers. I'm going to move on. All right, now what we need to do now is make our sign chart. This is just like what we did before, because I'm not really asking you anything different. It's just the numbers are really crazy. So down here is F prime, and up here is F. Now, how do you fill in the rest of your sign chart? You take a number, and what do you do with that number? You test it into the derivative. So again, if you hit the home key, I want to show you a couple of different ways to do this. I'm not doing this to confuse you. I want you to have multiple ways of doing it, so if you get stuck, you can do it a different way. All right? Especially when it comes to trig, the home screen may be easier, but it may not be. All right, so watch what I'm going to do here. I'm going to take a number to the left of 3, -4, and I'm going to store that. See the STO above the on button? I'm going to store that in for x. Okay? And then I'm going to go up, and I'm going to highlight the derivative. Okay? And I'm going to do this again. So if you're just watching this time, you can follow along next time. I stored -4 in for x. Now, what this is going to do is it's going to plug the -4 into the derivative for me. It's doing the work for me. Okay? You don't have to do any retyping. All right, now I get this, which is weird, but how do I turn that into a decimal? Diamond enter. You should be comfortable with that at this point. Okay? Now, let's say you don't like that. You don't like it. Okay? Here's another way of doing it. Go to the table. Look up a negative number to the left of -3 and look at the y value, because remember the derivative is what's in my y equals. This is another way of doing it. That's another way of getting a positive. You could go to the graph. Look at the graph. For numbers of x that are to the left of -3, what type of numbers are you getting for your derivative? Positive. Because this graph is representing the derivative. So those are 3 totally different ways to get a plus and an increasing. Okay, so let me show you one more time, and then you can do the last one on your own. So what's a number between these two? 0, probably. That's what we'd pick. So if I go home, now I can store 0 in for x. So I just go 0, store, x, enter. So temporarily, my calculator knows that x is 0. I go up, and I find the derivative. Okay, and I press enter. And then if you want to go ahead and do diamond enter, that's cool too. And I get a negative number. Okay, I could have also gone to the table, and I could have found 0 on the table, and I found a negative. I could have also gone to the graph and said, hey, when x equals 0, and like F3 is trace, you can trace where 0 equals and see that it's a negative. You have all these different ways of checking these points. You're probably going to find one that works best for you. So go ahead and do the last one. You may guess kind of what you think it is, but go ahead and confirm it. And while you're doing that, I'm going to go ahead and fill in the rest of this. And this is not anything different than what we'd already been doing at this point. Once you have the sign chart, it's just reading the sign chart and putting your justifications. So the hard part here is finding your critical numbers and then testing them. That's really the only difference in this problem and what we had already done. All right. Now, because you stored something in for x, what do you need to do? You need to clear it. Okay, so if you stored something in for x, like how I did, you need to go second F1, you need to clear your variables. Because otherwise, when you do the second derivative, it's going to mess up if you don't clear it. All right, so I said something about second derivative. What on the paper told me I needed to do second derivative? Concavity and point of inflection. So how am I going to find the second derivative? I just differentiate the first derivative. So I differentiate this thing right here. This was the first derivative. So I differentiate that. You don't have to retype it in. And then comma, x, close parentheses. So that's my second derivative. What do you do with your second derivative now? Set it equal to 0. And now you have many different ways of doing this. You can use the solve feature on the home screen. You can graph it and find the 0 that way. So go ahead and see if you can find the number. There's only one this time, 1 point of inflection. So go ahead and try that part on your own. Oops. And if you ever get frustrated with how long a calculator takes it to do something, just think, if you had to do this by hand, it would take you like 10 times that long. Probably more than that, probably like 100 times. Like when people used to have to do stuff by hand before calculators.
What's that mean when it says they produce false equations?
Okay, so with trig, it sometimes gives you really weird answers. This is why I want you guys to have another way of doing it. When I do these, I don't ever do this. I just know that sometimes this is like an easier way of doing it, but it sometimes gives you really weird answers. You'll know when you get a weird answer because it'll look really weird. That's when you want to use the graph, okay? So this is the number you should have gotten. Now you still need to do your sign chart. Is that it? -8. 8 to 8. Whoops. So you either need to use the graph, or you need to, like, whatever you want to do. You on the cell phone? I kind of like the graph because it tells you what to put on your sign chart. Did y'all pick up on that? When you graph it, it gives you the number, and you don't really have to do test points. All right, I'm picking up the pace on this problem. Okay, so concave down, -infinity to -1.828. What's my justification? Yeah, you guys should be great at justifications by now. And write yourself notes. Help yourself out so that when you look back at this, you remember how to do it. Now, it is important that you know that we only have a point of inflection because the sign changed. If you were to graph the second derivative, it has to actually cross all the way through. So we have to say because f double prime changed signs. Okay. So that whole problem, that was just all the same stuff we'd done, right? Just calculated. Yep. This new problem, we know how to do it, but I'm going to go ahead and tell you it's a little weird. And the first thing I want you to do is cross off the word maximum, and I want you to write min, or minimum. Okay, that was just a typo. I messed up. There actually is no maximum of this graph. There's only a minimum. All right. What makes this weird? I've asked you to do a min before, but what's weird about it? Of the product xy. So that's x times y. So when we do the derivative, we might have to do implicit differentiation. However, we don't. That's news, right? Because look at what y equals. They tell us. So instead of writing xy, let's write x and then write what y equals. This one little step makes the problem way easier. Okay? We could even call this f of x if we wanted to. Okay? If you even wanted to, you could distribute that x so that it's even easier than that. All right, we still have to find the min. So how do I find the minimum of this? Just think, what do we do every problem? We derive it. So I'm going to call this f prime. So we can do this without the calculator. Of course, you could use a calculator if you wanted to get the practice. What do I need to do with this derivative? Because I distributed the x. Because remember, it was x times y. So here is the x, here is the y. All right, we need to set this derivative equal to 0 to find the critical number. So solve feature on your calculator, solve it by hand. You need to figure out what x equals, although that's not going to be our answer. What are we getting for x? Negative 3/2, or if you had a decimal, negative 1.5. Okay, the reason this is not my answer is because I want to know what the minimum of x, y is. Okay, remember this is x times y. This is x times, I'm just rewriting what I already wrote down, it's x times this. So if you know what x is equal to, plug it in. Negative 3/2, and then plug it in again over here. And this is where you could do this without a calculator, but why not, right? It's Friday afternoon. Go ahead and use your calculator to solve that out. And that's your answer. Are we good? Okay, let's move on to the next page. Negative 27/4. Okay, number 3, let's call that homework unless we have time to come back and get it, but probably that one problem is going to be your homework. It's the easiest one on the whole page. All right, let's look at number 4. Okay, as I read this, I want you to think about what we need to do. Find the value or values of c, and keep in mind c is between 0 and pi. So my answer has to be between 0 and 3.14. It makes this function parallel to another function when x equals 4. So if two things are parallel, what does that mean? They have the same slope. In calculus, what does that mean? They have the same derivative. Yes, same slope, but same derivative. So what we need to do is we need to find f prime of x. I need to find g prime of x. And then I need to set them equal to each other. And I need to let x equal 4 and solve for c that way. All right, here's the bad news. Your calculator will not derive x squared sine cx because there's more than one letter. Okay? We're going to have to do this one by hand. But I'll help you with it, okay? So, product rule, right? X squared sine cx. This isn't really that bad. So, derivative of x squared, 2x. Then you just write sine, and I'm going to go ahead and put cx in parentheses. You don't have to, but it looks better for me to do that, and I'm going to do that. Okay, plus. Okay, let's think about the second part of product rule. This is where we just write x squared. And what's the derivative of sine cx? Cosine cx times c. Why c? And what rule do we call that? It's the M&M rule. Chain rule. I know, I'm asking a lot of you guys on a Friday afternoon. Okay, so think of it this way. If I said, what's the derivative of sine 7x? You would say cosine 7x times 7, right? Right? Okay, that's the same thing. All right, this is an easier one. Everybody, what's g prime of x? 4x. Okay, next thing is we're going to set these two things equal to each other. And remember, we get to let x be 4. Okay? So what would 2x, what are we going to write instead of 2x? 8. And then instead of cx, 4c. Good. Instead of x squared, 16. And I'm going to go ahead and write the equal sign equals 16. Okay, now I'm down to just one variable. So how are you going to solve this equation? Okay, so in the home screen, we could do the whole solve thing. If any of you want to do it, go ahead and start typing it in now because it's going to take your calculator quite a while to figure this out. All right, so let's use the graphing thing one more time. This is a perfect example of when I think graphing is easier. Okay, so watch this though. I could, everybody look at this. I could put the left side in y1, the right side in y2. But then I'm going to have to like go up and find the intersection up where 16 is. What I'm going to do instead is one tiny little thing so that it equals 0 and I can just use the 0 feature. Okay? Your teacher may have shown you this before. If they haven't, today's the day, now you know. Okay? This is, so we're going to graph this. We're going to put this in y1 and we're going to find the 0 feature. So let me go ahead and pull up the calculator. By now I have this like committed to memory, I think. All right, so 8. Are y'all okay if I put x in place of c even though it's not x? All right. Because we kind of have to, so I hope you're okay with it. Don't forget your minus 16 at the end. Stay with me, guys. We're getting real close to being done here. All right. I got to have minus 16 so that we can do the 0 instead of just an intersection. I don't like the way your calculator does intersections. It's really kind of weird. Okay? In fact, I haven't shown you for that reason. All right. So there that is in y1. Now, instead of just doing zoom 6, I'm going to pick my window. My answer has to be between what two numbers? 0 and 3.14. So watch this. In place of x min, I am going to put 0. What do you think I'm going to put for x max? Pi. I can type in 3.14 or I can actually just put the pi symbol and it does it for me. All right, what this is going to do, well, let's just go ahead and press graph and you'll see. There could be, and there are in this problem, other answers that are negative or larger than pi. We don't want those, so why even waste your time looking at it on a graph? I know this is a lot of stuff in one day. Most of it is just to get you used to it for next week. Okay, so we have 3 answers.
Wait, what? I'm sorry. What? Did you put 0 and 3.14 for x min x max?
Correct.
And then you just leave everything else the same?
Yeah. And then you just press graph. So here's my window. So y'all go ahead and find your answers. Find the zeros. So here's my window.
Oh, minus 50.
Do you have what I have typed into y equals? So you have the minus 16 and everything.
Oh, but I have nothing.
Okay, that would do it.
Wait.
All right, remember F5, 0, go to the left of the 0, press enter, go to the right, press enter, and there's one answer right there, 1.440. We got to go to 3 decimal places, so that's one answer. Okay, go ahead and find the other answers. I'm going to write them up here so you can double check it. Okay.
Wait, is your minimum 5 too?
No. So my answers have to be between 0 and pi. So my x min is 0 and my x max is pi.
Can I say when mine like disappeared when they try and
Are you doing F2 zoom again?
No.
Well, like, let me ask you this. When you typed it in, did you press enter so that it's like secured into Y1? I don't know. I'll look at it in a little bit, but we're going to move on for right now. Okay, let's all go ahead and go to number 5. We're going to wrap this up, okay? All right, I want you guys to get used to reading tables. So this is just an intro. You're not going to probably get everything out of this next 5 minutes. That's okay. Just if you get something out of it, you're good. So here we have T is greater than or equal to 0 hours. W is a differentiable that implies continuity that gives the temperature in degrees Fahrenheit of my house. Okay? So at the 0 hour mark, like when I start timing, this is the temperature. At the 3 hour mark, this is the temperature. I don't know for sure that it steadily increased the whole time. It possibly could. It possibly dipped down to even colder and came back up, or higher and came back down. I don't know that, okay? But I do know that it's continuous. And then I have some other, every 3 hours I looked at the temperature. Okay, so the first part is something that you would have done maybe in Algebra 2. The first question is a really simple question. What's W of 3? You read the table, and you find that W of 3 is 72.3 degrees Fahrenheit. And what is the meaning of it? It's the temperature when?
3 hours.
At T equals 3 hours. It's not the temperature over 3 hours. This is representing one temperature at one point in time. That's important for where we're going with this next. Okay, so for the next part, find the average rate of change of temperature over the first 3 hours. So now we're talking about over a period of time. Okay, so average rate of change, that's AROC. What does that mean? Yeah, so in this case, I'm going to use W of 3 minus W0 over 3 minus 0. We call this the difference quotient. This is just like slope formula, slope of the secant line. Change in temperature over change in time. So that's going to be 72.3 minus 68.7 over 3. So go ahead and use your calculator to crunch those numbers. And go ahead and write your units and think about the meaning of this. What does this mean in this problem? Are you getting 1.2? And our units are degrees Fahrenheit per hour because it's the rate of change. So what does this mean for the problem? It means that my house on average warmed up 1.2 degrees Fahrenheit per hour over the first 3 hours. It does not mean that that is exactly what happened. Like every hour it was 1.2 degrees warmer. I don't know that for sure. Just on average, this is what happened. Okay? At hour 1, that's the rate, about that was happening. At hour 2, that was the rate. Okay? So then we get to part C, which is a little bit different, and look what it says. It says estimate W prime of T. Now W prime of T is an instantaneous rate of change. And I'm going to go ahead and say W prime of 1.5 and then put the little squiggly equal sign because this is an estimation. So W prime is the rate of change. So I'm asking you to estimate the rate of change at the 1.5 hour mark. How much what's the temperature change in my house? What do you think? What would you guess? So not what's the temperature, what's the rate of change of temperature? Okay, so I'm hearing a few different things. And Christy, you said 1.2. Why did you say 1.2?
Because for the first 3 hours, like the rate of change was 1.2, and so we're seeing 1.5 is like the same for the other.
Yeah. So since 1.5 is over, we said on average, my house was getting warmer 1.2 degrees per hour. So at the 1.5 hour mark, if I had to guess, I would guess, hey, it's probably getting warmer at 1.2 degrees per hour. Okay, I don't know if that's really what happens. This is just an estimate. All right, now some of you, this is a little unsettling because you're like, well, we don't know that. And you're right. We don't know that, and that's why I didn't put an equal sign. This is just an estimation. Okay, in fact, it didn't even have to be 1.5. I could have put 1.9 right here, and you would still give me the same estimation. Okay? This is the instantaneous rate of change at the 1.5 hour mark. What's the theorem that tells me that these two things are going to be equal at some point in time? Mean value theorem. Very good. Mean value theorem. Okay, so last thing. Are y'all ready to wrap this up? Okay. Is there a time when W prime of t is guaranteed to be 0? What I mean by this is there a time when the rate of change, it isn't changing? Like it's not getting colder, it's not getting warmer. Is that guaranteed to happen?
Yeah.
Some of you are saying no, and some of you are saying yes. Look at the whole span of time and look what's happening. It looks like my house is getting warmer. And then it gets colder. And it could be going up and down all day long. But I know that it gets warmer and then it gets colder.
So probably on the...
It's like a curve.
It's like a curve. So if you think about it, the temperature in my house is a curve like this. And what is W prime representing on the curve? The slope. So is there guaranteed a time when the slope is 0? Yes. We do not know when that time is. But, well, I know there's not because of this word right here. I got you covered. That's why that was there. So what is the theorem that tells us this? You already said it, so just say it again. Mean value theorem. All right, now watch this. W, and I even made it a little bit more obvious on this. Look at that. W of 9 minus W of 0 over 9 minus 0 is what? What's the average rate of change on the 9 over the 9 hours?
0.
It's 0. So by mean value theorem, the instantaneous rate of change must also be 0. Okay, I'm not asking you to understand this 100%. Just a little bit. We're going to get used to it, okay? All right. Your homework is to do this one. I'm going to go ahead and wrap this up. You could probably knock it out right now before you leave, though. Okay?